All right, let's begin. My name is Dan Butterworth, software engineer here at VSI. Been working with OpenVMS now for 42 years. Like many, I'm an ex-Decky, an ex-Compacky. And I have been working on these products, most of them, a lot of them since day one, especially Console Manager and such. I was actually one of the original developers of that. So let's begin. So we're going to start off with talking about performance management. Then we're going to move to job management, and then we're going to VSI console management. I'm going to do a little bit more of a deep dive probably into performance management and job management because there's so much to those products. So jump right in, VSI performance management. Basically what we've got here on this display is this is our graphing system. We can essentially pull up graphs of historical data. We can perform real-time monitoring if we wish. We've got threshold-based graphical views of problems. You can actually do a playback of past performance. So I can go back later, draw the data that I've collected, and play it back at any time that I wish. We've got so many graphs in here, even after this many years, I don't think that I've actually looked at them all because there's so many different possible combinations that you can do. So we can monitor performance and resource usage of whether it's a standalone system or a clustered system. We can identify bottlenecks and hot files. So which files are getting the most activity. We can understand our resource utilization and our overall workload demands. And we can get detailed reports of historical performance. By that, we have a rules-based analysis engine within the product that will provide recommendations for tuning changes, et cetera, and identify problems. So, and the rules, we'll get to a little bit more of that later, they are customizable by the user. And of course, we got your typical performance statistics reports. And what I really like now is we have the ability to export performance data in a CSV format. So you can make some really nice Excel graphs. Moving on. So here is an example of a rules-based performance tuning. Now, this is from an older system that I had a long time ago. You can see it dated, 2001. So basically, it's telling us that we've got a disk that has exceeded the system-wide split I/O rate, for example. So there's many, many, many rules in here. We've got a complete knowledge base of factory-defined rules. As I mentioned earlier, you have the ability to add user-defined rules. We've got automatic data collection. You can actually have more than one collection. You can customize the collection to your needs or change it. The existing collection, which is always a default collection. And you can archive data for data analysis. We've actually run into some interesting situations where we've got data sets that are so large that they, between the programs and data, they will not fit in 32-bit programming. So we've had to use some archival tricks to get past that. And we do both graphical user interfaces and character cell interfaces. So let's go take a look at some more reports and graphs now. This one here, I actually pulled this from one of our test clusters that has an alpha, 2 Itaniums, and an x86 virtual system. And so what we've got here are the node averages and such. This was actually produced on the x86 system and such. We've got a lot of different things here showing us the different cluster CPU averages, cluster IO averages, hard and soft fault rates. There's just an incredible amount of data on the screen. And as we can see here, pointing out the bottom, basically you have these selector buttons here where we can scroll back and forth between the different reports that we have available. And then this here allows us to pick any particular node. So I pulled in multiple nodes here at the same time. So we could get, we want to go back and forth to the data collected from a different node for the same interval. Now here is a tabular report. We haven't forgotten the folks that want to use character cell displays. It's basically the same thing. It simply allows us to print it out at a character cell, and display at a character cell terminal. It's basically the same information as prior. There's like in tabular reports, there are as many tabular reports as there are graphs. So it's just an incredible amount of information. Here we have what we call our full analysis report. Now this is kind of pretty interesting. I see Claire back there. I was actually running UETP. I wanted you to know that. I was hoping you would come so I could see when you were talking about that. But yeah, as you can see here, we've got a whole lot of, we had quite a few processes waiting in resource wait SCS. And I could tell you from, whoops, I just pulled another Claire, didn't I? Yeah, really. Anyway, a lot of this, actually, as you can see here, that process there is actually part of the job management process. And we have a user out there, Debbie W. Did she use here? No, she didn't. Okay. I was trying to have a little fun with her. Anyway, so basically, and this is only one of the rule firings that actually occurred. And, didn't have enough space here to show all of them and such. But again, here we can cycle through, the different nodes that for which data I have pulled in. And here we can see from right here, there's actually other rules that I can scroll through to the right. Now, line mode graph in the editing panel. I like showing this because the default is to stack values on top of each other. And when you're using a typical filled in mountain style graph, sometimes the lesser values can become occluded by the dominant colors and such. So if you open this really slick editing panel, you can change from stacked to unstacked or mountain and line graph. So now we can see, what was going on here. So we've got 14 other processors on average, right? We see that Fathom processor 0 had really spiked there. I was probably running about 100 loads at the time on it. And, Boots is that's an Itanium box, if I recall correct. No, I'm sorry, that's an Alpha box. Boots 0 and Boots 15, there was clearly, something going on there as well, but not very much, as you can see by the, how short these curves are and such here at the bottom. But the editing panel is really great because it also not only lets me change these, but I can also cycle through my graphs from here while maintaining all of these settings that I've already applied. So it's a really very, very great place to review my data. Then, same information displayed as a pie chart. If you like that visual better, you can do so. So basically, exact same information. We see once again, oops, Fathom here at 70.6, still top physical processors, busy, etc. I changed a few little things on the graph panel there as well. I was just, like playing around, showing different things. But, and here, of course, we see our list of nodes, Barney, Itan 1, Boots, and Fathom. Debbie, you arrived late. I was picking on you earlier, so. And here, yes, we still support Regis terminal graphics. So that is a deck. What's that? Yeah, and so, but basically, I pulled up, a similar graph here. In this case, it was just memory utilization just for Fathom during this time, from the 15th to the 23rd. We kind of see what was going on there. Again, we're seeing my spikes in with the UETP test running, and then it just kind of settles down. Then I took that same graph and I saved the data as a CSV, and then I pulled this into Excel. So it's gotten a lot better. It used to be in when you had the graphing wizard in Excel, you had to like tweak around and play around a lot. With the current version of Excel, I pulled this in and I had this done within a matter of seconds. It was ready to present. So it's very, very handy. It gives you a lot of flexibility. Because there's so many different graph types and such that I can create in Excel, or charts as they call them. Excuse me. So anyway, so what we're seeing here, a little bit broken down into, the different categories and such that we have of memory utilization. We see here that in this color here, the bulk of our memory utilization was right there. Looking at the right. Oh no, I'm sorry. It was IO cache. Then there is the performance real-time interface. This allows you to create graphical user interface where you can either view the data that's been already recorded or as it's being recorded, or I can specify a remote node. In this case here, I was on the x86 system and I used what was called mode equals network. So I started that, which caused the real-time agent to start on system ITAN1, and then it gave me these basically bar graphs and strip charts. So yeah, and I went back over there and I fired up a few UETP loads as well too. And this one is so customizable. I mean, you can sit here literally for hours and create your own graphing panels and just, I mean, it's very hard to even discuss it in just such a short time like this. It's one of those things you simply have to sit down and use it.
Yeah. Once you create that, you can save it.
Yes, absolutely. Once you've created, that's right. Yes, there's actually basically it's a PSPA dollar real-time underscore defaults.dat, if I remember the file name. Exactly.
You can have multiple ones. You can just
Exactly right. Great question. Thank you. Yeah, so you can set this stuff all up. You're right. So yeah, you can spend your time setting it all up once, save it away, and then use it again later. And believe it or not, there is an interactive character cell interface. You can run in PuTTY. You've got a set of single sequence keystrokes and such you can use and pick different things, and it still works, still there. So now we're going to actually look at a few of the character cell interfaces. Advise, collect, report. There's actually a pretty neat disk usage report, and I very recently had to fix a bug here. We had a situation where it was not working with disks greater than 1 terabyte. And so we have fixed that for Itanium, and we checked that in prior to the release on x86. So that is there. Basically, you can dump the performance data. If you just want to look at pretty much raw information for whatever category you want, you can do that. And that can get quite extensive, especially for things like process records, because we record information about all processes on the system. And so these can get very large. And so narrowing down your time frame or possibly using like one of the graphing interfaces to like find where you want to look at, and if you go and actually look at the raw performance data is probably the best way to go about that. And then there is a system PC sampler. It's similar to the PCS extension in SDA and such. I think most people have probably moved to the one in SDA now. I don't really get really had any support calls on that in a very, very long time. Next comes the advise, collect, add, modify command. This allows us to create what we call collection definitions. The default collection is named Default collection name is named CPD. Then there is advise performance report. This, same as the GUI, allows us to generate all those detailed performance analysis reports, save them to a text file, etc. And then there is advise performance graph, which is basically, this is how I generated the Regis graph and the CSV files that we looked at earlier. Oh, and that concludes performance management. Any questions? Yes.
The rules, for example, the AR stack like over 25 to 30% bags may not be the same.
That's right. And
have you
not for the x86 release, but they are modifiable. So that is something very easy to do. Yes, that is very easy to do.
I don't know the rules.
Right. Right. Those are out there. We can change those at will, and you can change them to meet your needs if you choose. Yes.
About fiber channel data.
Great question. That is something that we do not collect at this time. If that's something that you need, we really need to know that kind of information, right? So you're looking for things like on the various fiber channel devices and
Exactly.
okay, very good.
Also, latency.
Okay, okay.
That's
Basically the network interface data. Okay, okay. That's great. That's the kind of things we need to know.
there's a whole bunch of stuff that just got added to the new land drivers.
Oh, sorry.
There's a whole bunch of stuff that Stock Gallon Company just added to the new land drivers.
Yes,
Just need to pick the data.
right. Exactly. That's exactly right. Yes.
How would you compare T4? Are they complement each other? Are they fighting with each other? When would you pick the one? Would you pick the other?
From feedback I received from people that use T4 and this, they prefer this, but T4 has some very interesting correlations and such between the various pieces of data that I feel that we should have those kinds of things in this product. Yes. So. So the CSV file? Oh yeah, that's exactly what I did. I pulled that over. John? Right. Yeah, I pulled, let me go back for you. Oh, there we go. There we go, right there.
Yeah, that's Excel, but that's
Right, did you put it in through, he's asking,
Tilda.
that's in Excel.
I would expect so. I mean, it's just a CSV format file. Nothing special about it. I'm sorry.
Teal does require header, but
Okay. Right. No, it doesn't sound okay. Because that's something also we need to be aware of. Thank you. Yes.
Good question. My apologies for arriving late. What's the product name for this guy again?
This is VSI Performance Management for OpenVMS.
So this is what used to be XPS, and then was
Polycenter.
and then it was Peter Associates Solution, but it's back to VSI now.
That's right. Exactly correct.
Oh, so you guys got it back from
That's right.
Okay.
That's right.
Oh, okay.
Yes.
Oh,
Yes.
okay.
I'm the man from Broadcom.
Oh,
Okay.
Yeah.
Welcome home.
Yes. Thank you. Yes. I am very grateful to be here. Okay. Very.
I was like, this looked like something that I ran on my Alpha workstation.
It probably is exactly what. Yeah.
Okay.
Right. Yeah.
I loved it.
Thank you.
No, it is. It's great tool.
Over the years, even at CA Broadcom, we took very great pains to maintain the compatibility across. I mean, the fact here, like I said, I pulled in from x86, I pulled in data from Alpha and i64 in the same session. So, and I'm not gonna say it. Jan would probably want to hit me if I said it anyway.
Yeah. What's the implication of, the 5-minute selection?
2 minutes.
2 minutes.
It's 2 minutes.
Okay.
Right. It's 2
Is
minutes.
there a big overhead cutting it down?
Well, basically, you would essentially almost double your overhead. You would essentially do that. Yes, yes, and that can be, costly on something with a lot of processes. Yes, I'm sorry, Keith. I think you had your hand up first. Go ahead.
I thought I heard that VSI could also the PerfDAT, which was a tool written at HP to sort of replace this. Was I not correct in that? It was related.
That's yes, I don't know what his future is though.
Okay.
Yeah.
So VSI has that as well.
Yes, I mean, yes. With the tool itself, no, because it has a very specific record format in the database. It is, unique to this product. Yes.
You might want to go look up Steve Lyman and find out if you could get TL Viz.
Okay. All right. Steve Lyman.
he had a company that was called like Little Things Matter or something like
Okay.
that. And TL Viz is this with the headers that Keith just described and the ability to do correlation.
Okay. Okay. Is that LYMAN or LIMAN? You know? OY? Okay. Great. Anything else? So, I'm going to go into VSI job management. Just many of my customers, especially that guy right there, use this very heavily. Yes, this used to be known originally. Its original was Deck Scheduler, then it became Polycenter Scheduler, and then went through CA Broadcom, and now it's back home where it belongs. So basically, this is an OpenVMS scheduling, execution, monitoring, and recovery product. You got two components: the manager and the agent. The manager typically runs, as we'll see later, in clusters and such, and I'll talk about that more. And the agent often, runs on a standalone box or maybe, one or two nodes in a cluster. Now, one of the most powerful things about this product is the job dependency trees. What we see here is a really, I'm sorry? Oh, okay. Yeah. Anyway, this was a really simple dependency tree that I created. And so as we can see here, we have this job on top. Basically, this shows the flow. All right. Basically, what the icon's telling us is the last time it ran to completion successfully with the green thumbs up. And then it's scheduled and such to run. And this one here is the same thing, but it is, we'll have to wait on it will have to wait on its successor. So in other words, this job will wait indefinitely for this job to complete successfully once again. Okay, so if it completed at, say, noon today, for example, all right, this job, rather say, completes at noon today, then the successor has to complete sometime after noon on a future date, today or whatever. So it completely manages that for you. Once you set it up, it's done. Now you have, certainly it can be changed. I know, you periodically modify your job database a lot, but many it's that I have worked with, they've set this stuff up and they leave it alone. Next, we have load balancing across cluster nodes and within what we call load balance groups. So the load balance group is very important to understand because you may have on a cluster different nodes with different application loads on them. Maybe you've got an RDB running on 3 nodes. Maybe you've got something else running on another 4 nodes. Load balancing allows us to specify the group of nodes which any particular job can run, and it will load balance only within that group. So if I specify that, all the RDB jobs run on these 3 nodes and, say payroll, theoretically speaking, hypothetically speaking, rather, runs on the other 4 nodes, we can load balance them independently. And we also have real-time monitoring of job execution. Screen is kind of small here, but hopefully you can see that. We have our little running man icon down here. So this job is actually executing. And of course, we have notification of whether the job, success or failure. We also have calendar functions within inside. So you can define your own fiscal calendar however you wish. It is very flexible. And the last thing on this screen I should have gone to, this on the bottom here is actually this is actually the one of the other monitoring screens showing us what has been going on here. I know the text is a little small and such, but obviously the stuff in green is simply telling us that, something has started or ended successfully. And then finally over here on this side, this is what we call the linear display. When you can't see, your screen or you're unable to keep the stuff you want within the scrolling area here, you can simply go over here in the linear display and pick a job and go right to it. So try to make it easier to navigate. for really, really large job dependency trees, this can get a little messy. You can imagine with all of these, imagine all of these lines running between all these hundreds and hundreds of jobs. So it can get a little messy at times. There was a plan at one point to enhance this with some better routing and such functionality, and that is something that we definitely need to look at to make it much more friendly, because it does get, I just have to say, it can get rather ugly when you've got hundreds and hundreds of jobs. Yes.
I like the deck Windows interface.
Okay.
It brings back a lot of memories.
Okay.
Web interface, maybe?
Thank you for saying that. That is something that I would really like to see personally. And that's something I need to discuss with the manager. Yes, yes, Daria. Thank you. Yes. Cron. Okay. Well, I had a few discussions about that. Kind of iffy on how cron handles, dependency trees and such. I can tell you that based on what I've learned, and I may not be correct, that our dependency management and such is quite more robust than cron, from what I've researched, read about, and what I know about this product. So, unfortunately, we don't have cron on open. Well, do we have? Is there a freeware cron on OpenVMS right now? I didn't think so. Okay. No. Okay.
I believe it's called JSS.
Okay. No, I do not.
And a package called Mondesi.
Say that again.
Mondesi. Mondesi.
No, I have not.
It's a module that you can load into a web server, and when you browse to it, it runs a VMS client,
Okay.
and it actually gets VMS performance data and paints it on the screen.
Mondesi. Okay.
Mondesi.
Okay. Thank you.
And I think they did it for x86. I'm not sure.
Okay. So, already discussed the multi-architecture interoperability. We currently have this running in mixed architecture cluster with all three architectures in it. And here I was able to, capture a really good screen where you can start seeing some of the different things here. Some of these I purposely made them break. Did Debbie disappear? Oh, no, there she is. See? User Debbie, log in, no such user, Debbie W. So, but anyway, this gives you, this is really an excellent interface to use, because you're getting a real-time status update as this thing scrolls through. It's quite handy. Do you use this much, Sia?
I do use it, but I don't use the graphical.
Okay.
One question I had was, talking about the agent. The agent
Mhm.
is not. You don't need a license. Okay.
Well, things are with x86. We have moved to LMS, so there are little differences there.
But on the titanium platforms.
Well,
Agent.
Itanium had a completely that is still right now the old CA Broadcom licensing model, which was completely different. So I didn't use keys at all. So yeah, so with the agent, you're typically going to run that where you don't need all the functions of the manager. You've got some box out there. You need to run something on it periodically or whatever. That is the most common use case where you just don't need the full functions of the manager.
limitations I found. You can't have the pre and post.
Yes, yes, that's true. Yeah, we're actually going to talk about I'm going to dive a little deeper into like job records here. So right now, so the job creation window. Now, this once again was from the GUI. It kind of shows you the different kinds of fields and such we can have, in a job. And this is just a small subset of them on this screen. I think some of those important ones, of course, to point out here. Every job should have a name. I've had people create nameless jobs, and it's just kind of a bear to manage. Okay. Other obvious things, username, there obviously needs to be a username assigned to it. And then here, the command field. This can be a single VMS command, or it can be a very complex command file. Okay, the same with the pre and the post functions. We'll talk more about those in a little bit. But then you have what you'd expect, your output file. All right. This job is being created. So last exit status, as we see here, all right, is basically none. And this is the exit status for the main, we'll call this the job main function, the command, and then the pre and post functions. We haven't assigned a max runtime to this job. You can do that. Max stall time. What that means is if this job hasn't started within X amount of time since it was scheduled, you can actually have a stall time job. Perhaps you were trying to perform some operation in that did not occur, in some other job or whatever, or even say, some other that's completely independent of job management, whatever you're doing. And so this will crank up and automatically start the stall time job to do whatever it needs to do. Max runtime job, same thing. If you've specified how long this job should run and it exceeds that time, we will start off the max time job. And that could be something like send email or, whatever, you can get completely creative there. And so whatever you can do, but bottom line, folks, if you can do it in DCL, you can run it under control as product, okay, whatever that is. So then we're going to talk more about job security in a minute, the rights identifiers and such, but it gives us the ability to allow other users to have specific access to a particular job. I don't want to talk too much about that at the moment. I want to go to the next slide. Kind of should have gone here already, actually, but yeah, job name, 40 characters long, and then, of course, any valid command for the operating system, right, goes into here. Scheduling info. In this case here, this job, next runtime is never, maximum runtime is none, hasn't really even been completely set up yet. So it is in these areas here where I could actually, even when I create a job, say I want it to run the first time tomorrow, and then this max and run install times are there as well too. But see, I want to get to the, there we go. Schedule interval. This is the big one. Is this, you're going to base this on your fiscal calendar. You're going to use a delta time. You can even specify the schedule interval so that it runs continuously. So what you can have is you can have a job, say, at the very bottom of your tree that is basically controlling everybody else. And all the other jobs depend upon it. And so they sit there in what we call a dependency wait state, waiting for you to kick off this trigger job. So there's lots of different ways you could manage this. It's really flexible. Yeah, delta time, as you would expect, is very typical. Scheduling interval is a delta time. Then the next run time, by default, it is blank. You can specify what that is when you're creating one. Of course, it will get set based on your scheduling interval after the job completes at least once. And then the first execution time, that job scheduling intervals. Dig more into that. So we could have possible intervals are run daily at a specified time. We can do that, so we can specify an absolute time. Run hourly at an offset time, past the hour. Schedule the next run time after the start of this run, days, hours, minutes, seconds, instead of like the completion time. We can run it monthly on a specified day and time. And then, of course, already mentioned, you can schedule on a fiscal calendar and then the run continuously. Now, the special day calendar is really cool because if you say like have, take your company holiday calendar, that changes every year, right? So you at the beginning of your year, you can define your special day calendar and decide I'm going to run these on special days, not run them, place them on hold, whatever. You'd probably use this quite a bit, right, Jim? Yeah. Granting access to the job. Here we go. So this job name, we call it Weekly Reconcile. The owner is WW. And then this group field I want to talk about too in a moment. And then, of course, obviously like the email address. Now, here's the command. I specified this. So weeklyreconcile.com. We can see that last start, last completion, so basically I kicked this job off manually. I would had to have because schedule interval is blank, right? Next runtime is never. So, but here's the real thing I want to talk about are these rights identifiers. www.read, www.write, and www.execute. So that means I could create John S. user, and I could grant him www.read in the UAF, just like you'd think, and he'd be able to go and view this job. If he has www.write, actually modify it. If you got www.execute, exactly what you think. He can run the job. So it's very flexible. I mean, you don't have to grant privileges using this method. You can, yes.
Silly question. Email address, VMS email, or can you specify internet address?
Yeah, you can actually. It's better if you use a dist list for that kind of thing, is what I found with this product. So, yeah. Any questions?
You just adding.
Exactly right. Yes, right. Nothing special, nothing magic. Very easy. Yeah, right. OpenVMS rights identifiers. I'm not scrolling through my slides quickly enough here. I'm talking too much. So yeah. So basically, the OpenVMS rights IDs that grant the access as we discussed.
And you can grant and manage that with Web UI.
That's true. That's a great point. Thank you. So some of the advanced features here. Basically, you get to this from the prior screen. Execution mode is one of the important ones. We have detached, OpenVMS batch, or remote. That means that I'm actually running this job on a remote node. Then I have valid run days. Of course, this job is set to run every day, as we can see here. Of course, since this job, there is no batch queue or batch queue entry or any of this because I've specified detached mode job run. Then there's job retention, always, never, on success or on failure. So you can actually create one-shot jobs if you want that simply disappear, or never disappear if you want, which is most of the time retain job is always. I very rarely see anyone using the other. Remote job attributes. So this is when we are actually running a job on an agent node, user at node. There is no load balance group here. Notify by mail, this is set to never. Notify terminal, always. So you'll get a broadcast message as long as you've got broadcast enabled on your terminal. And then a few other fields here, like add delta time intervals to the start time or the scheduled time. So you can control which one of those, how you want it to schedule in the future. Opcom messages, no or yes. So we can capture this, information on the console. One really useful thing about that is if you're running Console Manager and those are appearing on the console, you can record them in the Console Manager. And if it's something that you want to take specific action on, you can let Console Manager do that for you. Yes.
Did that broadcast back? Does it do it replace that user pulls the user that's in the job?
Actually,
it goes to the console. Where's that broadcast go?
Oh, it goes to both places. Thank you for asking that question. I didn't make that clear. Right. So you could sit there at Dave Sullivan's terminal, and Dave Sullivan's going to see all of Dave Sullivan's job appearing until you get irritated and you set term/no prod, right?
Okay.
So
That's what I was wondering. It got to the terminal.
it goes to both. Thank you for asking that question. Thank you. Yeah. Oh yeah, notification options. So kind of, like I said, I'm talking too much and not forwarding through my slides. actually goes to Dave's question there. Notified by mail, Opcom messages, notify my terminal, so you can see it's and notified by mail on special day action. It's kind of a little special thing we put in there so that, if it is a special day and, maybe somebody's not really paying attention to that fact, right? And they say, hey, why didn't that job run? It's like, oh, yeah, it's a special day. So you can notify someone on there. Yes.
Can you specify the operator class?
No, we don't have that.
Okay. You might want to consider that.
Okay.
Because something which is underutilized in a VMS system is like user 1, user 2, user 3. So you could do reply/enable equals user 1.
Right.
And that's monitoring, say, the accounting
Right.
department's jobs.
Yeah, and that would actually be something, that would be pretty easy to implement, like with a logical name or with a list of operator classes, right? So that's a great idea. Oh, load balance groups. I want to go back to this now. In this case here, the load balance group has none in it because I did not assign one. But again, that is designed so that we can load balance among specific nodes, typically in a cluster that maybe need to run a specific workload, like your RDB or a payroll or an accounting function or something along those lines. And this is simply where you assign them. Now, this is something, a note about batch and detached jobs. The detached mode user environment is the same as any interactive login because of some kernel mode magic. We saw earlier that insked process. That insked process has a kernel routine in it that will change both the UIC and the username of the insked process to whoever the user is we're about to run. So you will get your user environment. So there's no need to use batch mode in order to get that. And I actually encourage you to use detach. And one of the things is our job end processing here is much more efficient because you can specify a termination mailbox to the $create process system service. You don't get that when you submit a job. We have to go through all kinds of gyrations to get that kind of information. Okay, it's quite involved. So in-job processing is so much more efficient when you use detach. And the reason I find most people use batch is because they're unaware of this kernel mode magic. Most people think, oh, I got to submit this under a separate username to make sure it runs right. Yeah, right. Yes, exactly. Any questions?
Yeah. So when you're using the detached mode, right?
Mm-hmm.
You run into the shared quota issue when you start going off of the same user, because everyone that you create, you start going to share the quota off at the UAF level.
Well, no, I
think you get a new process.
Well, they're independent. No, they are independent detached processes. They are completely independent. Yes.
Okay.
Yes. Yeah, they're not part of the same. I think what you're thinking, Dave, is like you have an OpenVMS job is a master PID and its collection of right. No, these are independent. And next, we're going to talk about pre and post processing. We saw earlier those pre and post functions that we had out there. What do you use them for? And what happens? Basically, it's just exactly what you think. I need to do something. Maybe that's, quiesce a particular system before I run the main function. I use the pre-function for that. Then I do whatever I need to do in my main function, and then the post function may re-enable it. But there is a hierarchy there as to what will happen. Actually, let's use a hierarchy, that there is a series of events that can affect our final outcome. So if the pre-processor step fails, main step is not run. Something's wrong. You need to go investigate. The job ends with a failure status. If the main step fails, the post-processing step is run. There may be times there, the whole idea behind that was, there may be something we need to go out and correct, and maybe we can correct that, and we could actually rerun the main function if we needed to. The job ends with the status of the post processor step is what will happen there. Best practice, there is a symbol here that we define, and there are many, many symbols that you have available to your jobs. They're all listed in the admin guide that you can use. But you capture the value of that in the post-processor step, so you can either, so that it is saved away so you can go investigate.
Are those symbols passed to the post-processor job?
No, they are available throughout the entire job, everywhere. You can see them. They are global symbols, so you can see them. You're probably wondering how we're pulling that off. There is, and I don't have a slide on this, there is an application that runs all of this. We have our own kind of front end, and we use like live $do command and things of that nature so that everything chains through really nice. And you don't have to worry about losing your context. So you can rely on the fact that these global symbols are there for you to intend. As I said, there's a whole list of.
Yeah, but like, let's say that your main job fails.
Mm-hmm.
Do you pass the NSCAD symbols for the main job into the post?
They would be available. Yes. Yes.
Right.
Yes. Yeah. Yes. Yes. Let's see. Yeah. Oh, yeah. And here we go. If post-processor step fails, continue on. Job ends with failure status, as you'd expect. Event logging and reporting. Schedule log basically shows you the currently logged classes of events, and there are many, many more classes than these. These are the defaults. A job event is what you think it is. Some abnormal event, we have defined what abnormal events are inside the software. Termination event basically is job management deaths. Basically, if the NSCAD process or whatever itself dies. An interface event. This is something we added in the last release. It was something that people really wanted because prior to this, somebody could go out and modify a job and you didn't know who done it. Now you know who done it. And then there's error traps inside the code where we've come across some other kind of condition and we need to track that and notify you of it. Again, there are many, many more log classes. Now, the reporting function provided by an application named VSS reports.exe. We got an example report on the next slide. So here, we've got all of our job finish, job starts, and of course we see here, system modified the job while on Node Fathom, and this was the process ID of who did the modification. So very simple, easy to report. Okay. Any final questions on job management? I'm running out of time. Glad I, yes.
Tony Johnson definitely is down all of them down. The hard thing is to create a schedule job / role. Show the dependency name, but you won't show the number in it's just some simple way to get these by job number.
Yeah, that's no is the answer. Yeah. Unfortunately, right. Yeah.
One quick thing. One subtle difference between running something as a batch job and running something as a detached job is $F mode is now other rather than batch.
Yes.
So if you have stuff that you said I need for batch jobs, you might have to go back to look at that if you're switching the way you're running the job.
Yeah, did you run any of that when you guys moved? See, I know you had some stuff running in batch, right?
We run everything. Most of the stuff. Okay. But we do have problems. I believe like 9,700.
Wow.
That we run. And
Wow.
our biggest problem is in order to do any maintenance compression files, we need to bring the schedule down.
Yes.
And that is a off shift.
Yes.
Any work on that
That's something that that's something that needs a very, very hard look. And what he's talking about here, folks, is, of course, the files that make up the database are locked as long as the inscat process is running. And we have a scat optimized command that will actually compress the database. And you have to shut down in the cluster. You must do that. There's no other choice. So, all right. Well, I'm actually kind of running into my question time. It's 11:52, so I'm going to have to whiz through Console Manager here. For those of you who use this, nothing is really this product has been around a very, very, very long time. It dates way back to the early 90s and such, when what we had were systems with serial line consoles. We connected those to terminal servers and et cetera, et cetera. And we used LAT protocol many times, and time went on and we got Telnet. But over the years, we have added Telnet and SSH connections. So basically we can talk to, anything out there that has got, a network console with some protocol, even if you have to run a custom application for that. Okay, we can get to it. Right? We really can. Now, SSH is the only way right now we have to afford any kind of security. There are, terminal, the new sexy name for them is console server, by the way. So there are SSH console servers out there that literally allow you to secure all of your old, serial port connections. You can do it. Now, the most powerful feature of this product, we're going to get to that in a moment, is the event detection and notification using what we call scan profiles and such. Basically, everything to the console is logged. That's what we're really telling you here, archival and audit trails. And then there is also the ability to fail over. You can actually have two console managers, one acting as a hot backup of the other, or one sharing the load. So you can actually have two boxes, half your systems maybe, or whatever number you want, are active on one, the other half are active on the other, and when one fails, the other one picks them up. Now, so I'm really running out of time here, but this is by far the product's most powerful feature. Basically, an event is a text string. Appears on the console, matches a user-defined pattern. That can be either a string literal or a regular expression. Events also have context. So you have lines of text around that mean something. For example, you see security alarm on and you capture that, right? But there's a whole, there's many additional lines of text in that message that came across. You define that using context. So basically, events are records in the config database. We have over 2,000 events already provided in there for you. We organize these into what we call scan profiles. So we have a logical grouping of of events, which are also defined in the config database. And we encourage and welcome people to create their own. We made this very flexible and very easy to do. Create your own or change what's out there to suit your needs. So basically, scan profiles are assigned to systems being managed. So every node could have its own scan profile, or you could have them all use the same scan profile, or whatever. Next, action routine. It's a command procedure or a program that can be executed when an event occurs. So we've got a fully published API on both DCL and programming. So you can do whatever you want with it, because we're basically going to hand you all the information about that event that we have, and then you decide what to do with it. By default, coming out, so we say out of the box with the product, we've got action routines to send an email. We can display a little window showing an event. It is deck windows. We have a window that scrolls events as they occur. We can actually send a standard SNMP trap to a receiver. You can send a broadcast message to a terminal. As I said, there are APIs. This is the central coordinator, aka the C3. This is your graphical user interface. The main window, and this is actually a picture of that cluster that we have been working with up to now. With there's a couple of notes missing right now. We actually have performance management and job management running on. And again, the C3 basically providing a graphical interface to your managed environment. Basically, it provides all the access you need by hovering and right-clicking on a system icon. For example, right here, I clicked over ITAN1, and these are the things I can do. I can connect. I can extract, review all the historical data. I can see the events that occurred, which is exactly what we're seeing right here. So as we can see here, we had just a general message from user system. And here on October 9th, we had a network login failure. And each of these events has a severity, by the way, and we use the 6 ISO levels of priority, which are critical, major, minor, warning, clear, and indeterminate. Next slide. And here, view the context of it. Remember, I said this a little while ago. In this case here, we had the network login failure. So I wanted to see the whole enchilada. So I simply right-clicked. I see network login failure. I can see what was going on. Remote node was anchor. Remote user was dev build. User authorization failure. I did that purposely because I knew that wasn't out there, and I was just tweaking around trying to generate some things for, but that is the context of an event. And you define what that is, and it's done using a very simple method. Basically, this is the match string here, auditable event. So there are both what we call context start and end fields. The start field is how many lines before this is the start of the context. In this case, it was 3. And what's the total number of lines? 1, 2, 3, 4, 5, 6, 7. So basically 12. Character cell interfaces, these all work great from PuTTY. Use it constantly. Connect monitor, that's basically how you get to the consoles. Extract lets you review the console logs. Dialogue, you can actually carry on what we call a dialogue with a console. You could actually run a shutdown from console manager using the dialogue interface. Oops. I don't know, I'm getting, is there someone else about to use this room?
Lunch break now.
Oh, lunch break now. Oh, okay. Okay. Wow. I forgot that. Okay.
You're standing between us and lunch.
Okay. Maybe we just need to go click. I mean, yeah. I'll do a Claire here and just go right to the end, right? Anyway. So, but yeah, this is basically a quick view of what the Connect Monitor interface looks like. Of course, I was running this from I actually clicked and opened the deck term from the C3. This allows me to access the console of the node by default. You're just looking at you're in what we call monitor mode, and you are simply monitoring the activity that's going on at this time. There's a complete command set down here, as we see on the next slide, where I can do all kinds of different things. You can actually, one of the powerful things this I want to mention really quickly is this command, find. You can actually search for text in the console log using this by going forward or backward. So no more having to search through things like operator log and such. Man, I don't have time to go through the rest of this. Gosh, I'm really sorry. But basically, this is what a configuration record looks like. I was specifically showing how you set up failover here. The primary host here is VLAN 2, and the failover host is Fathom. I just set this up just to show people, but basically, VLAN 2 is in control most of the time, and if VLAN 2 fails, Fathom would pick up the load, is what it would be. All right. And this over here shows my scan profiles. These are all, got a whole list of them out here that I could use. Log file location. This transport type pseudo terminal. Basically, if I have any kind of custom application that I can run under the control DCL and a terminal window, I can run that under control of Console Manager. Roll the clock back to the days of the LPS 40 print servers. Remember those guys? And you had LPS $40 console app. We ran them under control of products like this so that you didn't have to, you could manage everything in one place. Literally everything. That's it. You can go to lunch now.
I'm good.